Honors Algebra 2 Pre-Calc, and we are continuing with section 2.2, Properties of Exponents. So let's just dive into some fun examples. All right, so we're going to fully simplify on all of these. I didn't write that at the start of the example, but again, we're going to fully simplify all of these expressions. So let's go ahead and start with E3 rather. Okay, so one of the things to keep in mind is that there are multiple paths to the same right answer when you do these problems. As long as you're following all of those rules that we learned for exponents, even if you do it slightly differently, you can still get the same right answer. So a couple things I want to clarify. The first thing is I would suggest that you recognize that this is a -1 in front of the y to the 7th. That negative is not to the 7th power, it's a coefficient. It's a -1 coefficient. So there's two ways to do this, okay? So option 1 is to distribute the power first, okay? And option 2, which is going to get us to the same answer, and I don't care which one you pick, and I don't think you should do both of them, option 2 is going to be to clean up the inside first. So it doesn't matter which of these you do, and you're going to get the same answer at the end, and sometimes one of them is slightly easier than the other, but the honest answer is either of these get you to the same spot, and you're going to do the one that feels more comfortable for you. I'm only doing the two options so that you see that there are multiple options. Cool. So moving forward, and this is actually example 3 from the book. I don't always use the book, but in this section I've been using them. Our example 4 and P4 will not line up with the book. Okay, so let's see what happens if I distribute the power first, right? So two things I want you to realize. Number one, I want you to realize that that coefficient is actually a -1, right? And the second thing I want you to realize, if I can find my other marker, is that anybody that doesn't have a power secretly has a 1 as a power, right? So if I distribute this power, I'm going to get a -1 to the 4th, a y to the 28th because of the 7 times 4. On the bottom, I'm going to get a 2 to the 4th, a z to the 48 because of the 12 times 4, and a y to the 12th, right? If I clean up the numbers really quickly, because that's an easy thing to do, I get a 1 on the top, which is probably not worth me writing. A -1 to the 4th is a +1, which I'm probably not going to write. So I get a y to the 28th on the top. On the bottom, I have a 16, a z to the 48, and a y to the 12. Well, now I notice that I have y values on two different floors, so I'm going to have to get those into one expression, right? So I subtract top minus bottom and put the answer on the top. So the other way to think about this logically is it's sort of like a tug of war. Whichever side has the larger positive number is going to win. So the top has 28, the bottom has 12. The result, which is 28 minus 12, or 16, will end up on the top. If the bottom had been the 28 and the top were the 12, the number would have ended up on the bottom. So I'm going to end up with a y to the 16, right, because 28 minus 12, over 16z to the 48th, right? And that's going to be my answer for example 3. So that's one way to do it. If you went the other direction, and again, I'm not judging which of these is better, I just want you to understand that it doesn't matter which of these two you do. If you decided to clean up the inside first, the first thing you would have done if you decided to clean up the inside with this -1 times a y to the 7th over a 2z to the 12th y to the 3rd, right? To clean up the inside, the only thing you can really do to clean up the inside is put the y's together, right? So you can clean these guys up, right? Again, keep in mind that these numbers have exponents of 1 on them, right? So when I now distribute that power of, let me clean up first. So a -1 to the 1st, y to the 4th on the top, because 7 is bigger than 3, so that's where the number will end up being. And I did 7 minus 3, and then a y to the, z to the 12th on the bottom. If I then distribute this 4 power now, I get that -1 to the 4th, a y to the 16th, a 2 to the 4th, and a z to the 48th, which cleans up to exactly this, right? So it really doesn't matter which way you do this. As we get to more complicated problems, there will be more than two options. So at any fork in the road doing one of these simplifying problems, as long as you're following those properties of exponents and you're making sure that everything you're doing is mathematically correct, you will find that you and a friend might do very different steps along the way in different orders to get to the end answer, right? So if you're comparing your work with someone else, you'll find that it won't always line up. So try P3. You can go ahead and pause me. I'm going to walk right through. Again, I'm not going to suggest you do it in both options, but I am going to show you both options, right? So I'm going to show you option 1, where you distribute the power, versus I'm going to show you option 2, where you clean up the inside. right? Or are you going to clean the inside first, okay? Again, I don't care which one you pick, right? I'm just trying to show you that there are two options, okay? And again, the more complicated problems get, the more options there will be. So regardless, I need to recognize that this -3 actually has a 1 power on it, right? So what's going to happen is if I distribute the power, I get a -3 to the 1 times 3, which would be 3, a b to the 2 times 3, which is 6, a c to the 5 times 3, which is 15, over a c to the 2 times 3, which is 6, and a b to the 2 times 3, which is 6, right? I could then go ahead and clean up my coefficient. My -3 to the third is 3 to the third is a 27. Because it's a negative to an odd power, it will come out negative. So I'm going to get a -27. And then I notice that I end up with no b's at all because 6 minus 6 is 0. So I get b to the 0. And for the c's, I'm going to end up with a c to the 9th on top. Now, if you want to write the whole thing over 1, you can. It would be okay to write this with the 0 for b to the 0, c to the 9th. It'd be unusual, but it's not wrong. It would be okay to write everything over 1, right? Like another way to write this would be to say, hey, this thing is on top of a 1, right? This is the most likely answer, but the other ones are technically right. Now, if you had gone the other option and you had cleaned up the inside first, if you clean up the inside, you'll notice that the b's cancel right away. So you're going to have this -3, the b's cancel, right? So the b's are gone. So -3, b squared, c to the 5th, right? You'll notice that these are gone. And you'll notice that these give you a c to the 3rd on the top. So you're going to get a -3c cubed all over 3, which is a -3 cubed times a c to the 9th, which is, in fact, that -27c to the 9th, right? So again, different ways to get to the same spot. So for our E4 and P4, we're going to go ahead and start venturing into some slightly harder problems. There's my eraser. All right, so same thing, fully simplify, right? We're doing the same thing in all of these. So for my E4, let's see. I would ideally like to give you a kind of tough one. Sure, we're gonna do, well, that looks nice and difficult. All right, I'm actually gonna steal number 68. From page 99. All right, so in number 68, we're going to fully simplify, and I get this crazy monstrosity that, among other things, has brackets with my parentheses. So I have an x to the 5th, y to the 2nd, on top of an x to the -3rd, and a y. Close that. That whole thing is to the -2nd. And then I have a y to the -3rd over a 2x to the 5th, y to the -3rd over a 2x to the 5th, all to the 3rd. And then this entire crazy monstrosity is all to the -1st. Now, I'm going to go ahead and stop giving you options on this. That's not to say that there aren't other ways to do it, but this is a big problem, so it's not going to be sensible for us to walk through it a bunch of different ways. For me personally, with this -1 power on a bunch of stuff, the easiest way to deal with this is to clean up the inside stuff first. So I'm going to clean up each set of parentheses first and then deal with what happens after, okay? Well, yes and no. You can either clean up the inside, that's fine, or you could just clean up this entire inside and deal with the -1 after. It's kind of up to you. So I would argue there's not much I can clean up here, right? Other than putting the y to the -3rd on the bottom if I want, but I'm probably going to leave it as it is for now, right? So there's not much I can clean up here, but I can clean up this thing a little bit. So I'm going to go ahead and again, different day, you might choose different things. I'm going to go ahead and put anybody that's on the wrong floor on the correct floor. So this guy's on the wrong floor, and so is this guy. So I'm going to make this an x to the 5th, x to the 3rd. He's going to move up, right? And a y squared, all over a y, all to the -2nd, right? And I'm going to make this a 1 over a 2x to the 5th, y to the 3rd, all to the 3rd. Okay, and this whole thing's to the -1st. And again, this is one option. There's different ways to do it. Inside this set of parentheses, I'm going to go ahead and combine some stuff to make it slightly nicer. I notice that I can combine these guys to make an x to the 8th, and that I can combine these guys to make a y to the 1st on the top. So I'm going to end up with an x to the 8th, a y to the 1st, and I'm just going to leave it over 1, okay? Because remember, I didn't write the 1st here but anybody that doesn't have a power secretly has a 1, and that includes the number 2 down there, right? Okay, so, sorry, computer fell asleep. All right, so this whole thing is to the negative second, and then this whole thing is to the third, and then once I'm all done, the whole thing's going to get a negative 1. So now I'm going to go ahead and distribute those powers. So I'm going to end up with an x to the negative 16th, a y to the negative second, a 1 to the negative second, although that's not going to matter much because it's just a 1, times a 1 to the third over a 2 to the third, x to the 15th, y to the 20, or to the 9th, sorry. 3 times 3. Sometimes my brain is a little dead. Okay. All to the negative first. Now, when you multiply fractions, since it's multiplication, you multiply straight across. So basically, everybody on the top is on the top, and everybody on the bottom is on the bottom. So I'm going to go ahead and move this up to the top here and make this. I'll put the numbers at the front, so 1 cubed, not that that really matters, x to the negative 16th, y to the negative second. On the bottom, I'm going to have this 1 to the negative second times a 2 to the third times an x to the 15th times a y to the 9th, and that's all to the negative first, right? So you can clean up the inside now if you want. You can distribute the negative 1 now if you want. It really doesn't matter. I'm going to go ahead and distribute the negative 1 before I clean up. So I'm going to get that this is a 1 to the negative third, an x to the positive 16th, and a y to the regular 2, over a 1 to the positive 2, a 2 to the negative 3, an x to the negative 15, and a y to the negative 9. Now my suggestion, and you don't have to follow my suggestion, but my suggestion is at this point, the last thing I need to do to simplify is combine stuff. But in addition to combining it, it would be a whole lot easier if I bothered to move things to the right floor. So anybody that has a negative exponent needs to switch floors, right? So what's going to happen is all 3 of these guys are going to move to the top. So I'm going to end up with a 2 to the third at the top, because I usually put numbers at front, an x to the 15th and an x to the 16th, and a y to the second and a y to the 9th. And then on the bottom, I'm going to end up with a 1 to the third and a 1 to the second. So, seems to me on the top that I have an 8, x to the 31st, y to the 11th, and then on the bottom I just have a 1 to the 5th, which is just a 1, so the answer you're likely to see is an 8, x to the 31st, y to the 11th. Now, there are a bunch of different ways to get there. Even if I did this problem 5 minutes from now, or 10 minutes from now, or last year, or the year before, I probably did it differently. There are so many little minute choices you can make that are still mathematically correct, but take you in a slightly different direction, and that's fine. Sometimes, and this is one of the disadvantages to having us on video, sometimes I do something stupid, like I add wrong in a step, and somebody in class is able to correct me and be like, Hogan, you did 2 plus 2 and got 7. And I'd be like, oh man, I did that. So there's a chance that I did something dumb on any of these problems, because again, without you guys in the same classroom as me to correct me, you know, I do dumb things. The better we get at math, the sillier the mistakes that we make. It's true. Anyway, so we're going to do an E4 that's similar to this. Again, it's going to have multiple levels. You're going to have to clean stuff up as you go. So yeah, I'm going to give you an E4, or a P4 right now, okay? All right, so for P4, we're going to do number 67 on page 99, which may or may not be in the homework, because I frequently assign you odds. So there's a good chance that this is one of your homework problems, and that's cool, because then we'll have gone over it already. So I hate using z's because my z's look like 2's sometimes, which is why I put the line through them, but it is what it is. Okay, so we have a 3z over an x to the negative 4th, and that is all inside a 2, right? And then we have 3x to the negative 12, y z to the negative 3rd. So 3x to the, I think it's a negative 12. Negative 12, z, and then y, and then z to the negative 3rd. So y, and then z to the negative 3rd. On top of a 2xy to the 7th. So 2xy to the 7th. All inside. I also put the lines on my 7th, sorry. Also inside a negative 3. Yeah, okay. Cool. So, you can feel free to pause me if you want. I'm going to go ahead and walk through it. Again, the steps that you take might not be the same as mine, and that's fine, as long as you're using mathematically correct steps and you're landing at the same answer in the end. So the first thing I'm going to suggest you do is anybody that doesn't have a power, you go ahead and put a 1 on them, because both numbers and variables Anybody that doesn't have a power secretly has a 1. Now, I'm just going to go ahead and distribute the powers because I think that's easier. So I'm going to get that this is a 3 squared z squared x to the negative 8th on the bottom times a 3 to the negative 3rd x to the 36th, y to the negative 3rd, z to the 9th, over a 2 to the negative 3rd, x to the negative 3rd, y to the negative 21st. All right. So now, and remember, if I'm multiplying, I just multiply straight across, so basically anybody on top is still on top, right? So now I'm going to go ahead and take this opportunity to move anybody that's on the wrong floor to the right floor, because that's just easier. So wrong floor, wrong floor, wrong floor, wrong floor, wrong floor, wrong floor. Well, that's a lot of things on the wrong floor. All right, so all 4 of these are going to move up to the top. So the 3 squared and the z squared stay on top. So does the x to the 36, so does the z to the 9th. We'll deal with other stuff in a sec. Joining those 4 things on top are now the 2 cubed, well, I skipped the x to the 8th, but that's okay. X to the 8th, x to the 3rd, and the y to the 21st. On the bottom, then, are only the 2 things that switched floors, the 3 to the 3rd and the y to the 3rd. Okay, cool. So that's a hot mess. Now, normally I order things so that all the x's together and all the numbers are together, and I didn't do that yet, so we're going to do it now. Again, when you choose to do that stuff is kind of up to you. So I'm going to go this way because it's a little bit easier. So I'm going to put all the numbers at the front first. So I have a 3 squared and a 2 to the 3rd. Great. Now I'm going to gather all my x's. So I have an x to the 36th and an 8 and a 3, right? If you want to go ahead and add 36 and 8 and 3 at the beginning, that's fine. 36 plus 11 is a 47, so I can get an x to the 47 at the front. The only y on top seems to be the 21. And the only z on top seems to be the, oh, I'm sorry, there's z to an 11, right? Because there's a 2 and a 9, right? And the y was taken care of. Great, everybody's good. On the bottom, I have this 3 cubed y to the 3rd. Okay, so now all I need to do is clean up these things that have the same basis. Now, one option is you could figure out that this top is a 9 times 8 and get a 72 and divide by 27, and that's fine. But what I want you to notice is the easier option is that you get a 3 to the 1st, because 3 is the bigger number, 3 minus 2, in the denominator. Now, there's 2 ways to think about this, and I just want to walk you through the logic. You can't think about it both ways, okay? Either you do the m minus n, right? M was the top exponent and n was the bottom. So then if you do 2 minus 3, you get a 3 to the negative 1st. So you can either think about this as like a tug of war, which is usually how I think about it. I think, oh, there's 3 to a power on the top and bottom. Which power is bigger? Oh, the power on the bottom is bigger. Cool, the bottom's going to win. How much does the bottom win by? Well, 3 minus 2 gives me 3 to the 1st on the bottom. Or, the other way to think about it is 3 to the 2 minus 3, which is a 3 to the negative 1st on the top. Because if you do the m minus n approach, you're always landing with the power on the top. That's fine, but once you get a 3 to the negative 1st on the top, you'd have to flip it down to the bottom again. I don't care how you do it. I'm just pointing out that that's a thing. The other one that I have the same base for are the y's, and that's going to end up being a y to the 18 on the top. And again, in that case, it doesn't really matter which way you think about it, because if you do top minus bottom, you get y to the 18th. If instead you think of it as like a tug of war, you say, oh, 21 is a much bigger number than 3, the top wins. How many y's does the top get? It gets 21 minus 3, which is 18. So when I do that, I end up with a 2 to the 3rd, an x to the 47th, a y to the 18th, and a z to the 11th. And on the bottom, I end up with that 3 to the 1st power, just 3. So now the only thing left that I have to do is clean up that 2 to the 3rd, which is an 8. So my answer ends up being 8, x to the 47th, y to the 18th, z to the 11th, all over a 3 all by itself. And that's it. All right, cool. So there you have it. That's our E4 and P4. The textbook's not going to have you do a ton that are much worse than this, to be perfectly honest. Like, that's pretty much as bad as that gets. So what we're going to segue to now is we're going to talk about rational exponents. Since we did a couple examples in this video, I'm going to stop this video and I'll do one more video that involves rational exponents.